This is now guided practice 4.5. In this guided practice, we're going to see how we can use formal two-column proofs to prove that lines are parallel. We're going to start in the first problem here with a diagram, and you can see we've got lines A and B cut by a transversal. We don't know if A and B are parallel, but we are given that angle 5 supplements angle 2, and using that information, we are being asked to prove that the lines are parallel. Okay, so the first thing we're going to do is we're going to write down what's given. So angle 5 supplements angle 2, that is a given. And the rest of the proof is given to us, but we've got some missing statements and some missing reasons. So we've got to fill in the blanks, so to speak, and figure out what is missing. So the first is given. The second reason is that supplementary angles add up to 180 degrees. That is, by the way, the definition of supplementary angles. Okay, so we can really put this in parentheses. What we're really using is the definition of supplementary angles. Well, the fact that they add up to 180 is interesting, and the only thing we've been given so far is that angle 5 supplements angle 2, so it would seem logical then that we're being asked to put angle 5, the measure of angle 5, plus the measure of angle 2 equals to 180. Okay, because that's the only thing we could really apply this fact to. Well, let's move on. Now we're given the statement that angle 3, the measure of angle 3 equals the measure of angle 5. Let's take a look at the diagram. Let's try to come up with a reason why this might be the case. What does it look like as far as the relationship between angle 3 and angle 5? So I'm hoping that you see these are vertical angles, and we already have proven a theorem that vertical angles have equal measures, and that's what this statement is saying, that these two angles, which are vertical angles, have equal measures. So the reason here would be vertical angles have equal measure. Okay, good. So now we've got three statements. Two of them are equalities. And now we move on to our fourth statement, which is that the measure of angle 3 plus the measure of angle 2 is equal to 180 degrees. Well, is that something that we can derive from this diagram? Let's take a look. Measure of angle 3 plus the measure of angle 2 equals 180, which we know means that they're supplemental. And that's saying that angles 2 and angle 3 are supplemental. Well, can we derive that from this drawing? No. Okay, if we knew that lines A and B were parallel, if we knew that as a given, we could then conclude, because of the same side interior angle postulate, that angles 2 and 3 are supplemental. But we're not given that A and B are parallel. That's what we've got to prove. Okay? The only thing we're given is that 5 supplements 2. So be sure you are clear on why we can't use the diagram at this point to tell us that the measure of angle 3 plus the measure of angle 2 equals 180. So if we can't use the diagram, then that means we've got to, well, it's either the reflexive property, which is obviously not the case here, or it's being derived from earlier formulas. So let's take a look at the two prior equalities and see, is there a way we could use statements 2 and 3 to derive statement 4. And I'm hoping that you see that we can substitute. Okay, so we could take the third statement, which is measure of angle 3 is equal to the measure of angle 5, and therefore supplement measure of angle 3 in instead of measure of angle 5 to get measure of angle 3 plus measure of angle 2 equals 180 degrees. So we could use substitution to get this statement. Well, we already made allusion earlier to the fact that if these two angles add up to 180, then that means they're supplementary, again because of the definition of supplementary angles. Okay, so we can now say that angle 3 and angle 2 are supplementary. Okay, so remember the definition of supplementary angles goes both ways. It's a biconditional statement. So it's an if and only if statement. So angles are supplementary if and only if their measures add up to 180 degrees, which means you can go from assuming they're supplementary to the fact that their angles add up to 180, or you could start with the fact that their angles add up with to 180 and that therefore they're supplementary. So we can go both ways with that. As with all definitions, they're if and only if. And then finally, we are concluding that A is parallel to B. Well, how can we conclude that? We said earlier we didn't know that. Well, now by doing what we've done, we've gotten up to the statement that angle 3 and angle 2 are supplementary. These are same side interior angles. Okay, and the converse of the same side interior angle postulate allows us to conclude that these angles are parallel. Remember again what the same side interior angle postulate was and what its converse is. The same side interior angle postulate tells us that if two parallel lines are cut by a transversal, so we're starting with parallel lines, then they're cut by a transversal. So let's review again. I'll just make a little notation over here in the corner. The same side interior angle postulate says that if we have two parallel lines and they're cut by a transversal, then the two interior angles on same side interior angles on either side, we can choose either side, I've chosen the right here, but that the same side interior angles are supplementary. Okay, but the converse says that if we have any two lines cut by a transversal, even if we don't know that they're parallel, but that we have the same sides in interior angles are supplementary, so we're given that these are supplementary, we can then conclude that the angles are parallel. Okay, so it goes both ways, and the converse of the same side in interior angle postulate allows us to conclude that if angles 3 and angles 2 are supplementary, then A is parallel to B. So this would be the full proof of this theorem right here.